Hello? Works? Yes. Oops.
Does this one? Yes.
Yeah? Okay. So, I suppose we're starting now, as at least there was this countdown. So, very much welcome to our cybersecurity and energy transition panel session. This is not a normal panel session maybe, it's more like a storytelling session. And we're trying it out the first time, so let's see. What's going to be different, we're going to give a bit more insight into each thing we're going to be talking about, so it's going to be a bit more research maybe. But then we also have our esteemed experts here, who are then going to hopefully even challenge us a little bit. Well, my name is Petra Berg, and I work as a postdoctoral researcher and a project manager at the University of Vaasa, and VEBIC, Vaasa Energy Business Innovation Center. And with me, I have two of my team members from a project called REDISET. I'm going to talk a little bit more about the project as we go. But now maybe Linda wants to say a few words.
Yes, hello everyone. My name is Linda Turtola, and I work for the Marketing and Communications Department in University of Vaasa. My research interest includes how legislation shapes the energy business.
Hello everyone, my name is Bahail Tahawi. I'm a project researcher at the School of Technology and Innovation, University of Vaasa, and I'm also working for the digital economy platform. My area of expertise comes from the IT, and I work mainly on projects related to cybersecurity from an educational perspective. I also would like here to introduce our other colleague, Mazahir Karimi, who's presenting us today at the Resilient Day and Risk Days in Newcastle. So Mazahir Karimi is an associate professor working also for the School of Technology and Innovation, and his area of expertise is more towards the operational technology, and I'm gonna be handling his part on his behalf today. Thank you very much.
Yeah, thank you. And actually I forgot to say that my research area is in marketing and sustainable development, so looking a lot at energy transition issues and also these socio-cultural aspects of transition. And with these words, next slide please, and then we have our expert panelists. And I think, Reino, you can start by introducing yourself.
Okay, thank you. My name is Reino Virrankoski. I work as a postdoc researcher at the Department of Information and Communications Technology at Aalto University. And I also teach part-time at the National Defense University and contribute with Autonomous Systems Research Group there. I have my background in control engineering, automation, in particular wireless automation. And I have also done some work with the electricity distribution systems. Thanks.
Thank you. Sonja?
My name is Sonja Balein. I am a professor in Sustainable Integrated Energy Systems at KTH, and I also work at DNV as a business developer manager. My expertise is the power system, the electrical power system as a whole.
Thank you. Olli?
Yeah, hello all. I'm Olli Rajala, working as a cybersecurity consultant at Hult. Hult is almost 500 employee consultant company with electrical, mechanical, software design, and then our cybersecurity team. I'm working there in industrial security side, so basically I'm eating IEC 62443 as a breakfast. And I have background in ICT side, complex ICT systems, and in OT, IT side. I've been working as ICT manager in one software company, and then designing and operating various communication and IT systems for power grid companies, how they can control and monitor their power grids. And before joining Hult, I spent a few years at Hitachi Energy as the cybersecurity architect for MicroSCADA, so I have some experience also from software development side.
Thank you. Hertta?
Hello, my name is Hertta Hytinantti. I work as a lawyer at Bird & Bird, which is a global full-service law firm. And I work at the data protection team, where I assist clients with data regulation and cybersecurity regulation. And recently, especially, I have assisted with the new NIS2 directive, which is very important also in the energy sector.
And Ross?
Hello everyone, I'm Ross Bailey. I'm a senior cybersecurity expert in Wärtsilä. So I'm working in the cyber operations team, which has a SOC, Security Operations Center, but I'm working more on the proactive side, so around phishing, emails, and awareness, and dealing with external collaborations also. But I also have a focus on OT, and I've extensively worked in OT asset management. So just hook me up if you're interested in that area. Nice to meet you all.
So thank you very much. And yes, I'm going to give you a bit of a background and context first, and before we let the story begin. As I said, it's going to be a bit more like a storytelling flow to this, at least we hope it's going to flow. So you're going to get a lot of teasers of very different perspectives. So we're going to have time afterwards for questions and some discussions. So we've been promised that we can stay here a little bit longer. And so if there's something you really want to ask or you want to, then you have the chance after the story itself. But yes, the next slide, please. And the next slide, please. So as a background to this panel session is the project REDISET, which is the Resilient, Sustainable Digital Energy Transition. It's an oh, actually, I'm supposed to read my paper now. And put on some glasses, that helps. Okay, here we go. So the REDISET consortia is coordinated by KTH in Sweden, actually by Sonja. And in Norway, we have FFI, which is the Norwegian Defense Research Establishment as partners. Then in Finland, it is the University of Vaasa and managed by Webic and, well, kind of me. And our project partners also include Statnett, Svenska Kraftnät, and Fingrid, so who are the TSOs of the above-mentioned countries. And then we also have the Norwegian Microgrid Center. So as you can maybe guess, this is a very multidisciplinary consortia. It includes technical research, IT, defense, as well as business and consumer behavior research. And we started in March 2022 and will continue until March 2025. And REDISET is funded by the Norwegian Energy Research, Business Finland, and the Swedish Energy Agency. Next slide, please. So what's the background? Why do we need a project like this? And especially a systems perspective. And we all know that the digitalization of our energy systems, especially the electricity distribution system, is considered a very necessary step to enable this so-called green transition towards renewable energy and more sustainable societies. This system-level shift from fossil to renewable energies include, for example, coupling of different energy sectors, connecting a variety of small-scale electricity producers to the grid, developing and improving smart homes and IoT technologies, as well as building more large-scale transmission and distribution networks. And even if this rapid digitalization entails a lot of opportunities, the transition also comes with its challenges. And to create more understanding about the cyber level of this energy transition, our project REDISET explores these requirements, especially in the Nordic sector, to secure a future digitalized energy system which is secure and sustainable, and that's why we focus especially on electricity transmission and distribution. Next slide, I think. No, yes. So, a little bit about what we do in our research. During our research this far, and more specifically in the work package 2, we have developed a system model. And that includes the 7 domains you see here. So we have the market system, control system, transmission and distribution infrastructure system, supply system, demand system, and disruption system and social cultural system. What makes this project and maybe this model different is that we are also putting a lot of emphasis on understanding the social cultural. So we are not only looking at the typical technical and IT, but we're also including the human aspect, as well as the disruption aspect, so what could probably happen. And the fact that we consider these 7 dimensions, they all apport to one very central thing in our energy system, and that is the energy system balance. And in electricity transmission, we know that means that it's the voltage and the frequency that have to maintain the same all the time. And for those non-technical people like me, voltage is like, which way around was it? Okay, frequency means how often, and voltage is about how much electricity is sent through the system. I told you there's going to be a bit of show. Okay, I should actually stay to my paper and not start thinking out loud. So what we are, and this work package 2 is something that we've finished. And what we're doing now is we're working in work package 3, led by the FFI, where we are doing this risk matrix. So we are actually then taking the worst possible scenarios from all these domains. We're working with different experts to score the level of risk, and then we are going to model them in the future to see where the short-term biggest threats are and where the long-term biggest threats are for the Nordic energy system. And also we are working then on work package 4 with our team in Vaasa, and that's the social manipulation checklist and this kind of guiding manual for businesses and policymakers in what to think about when working, like starting to look at cybersecurity in the energy sector. So that's the background for why we are kind of here today. And so is that the last? Do we have one more slide? Yes. Okay. So finally, to stop this rambling, as you can hear, everything is becoming more and more interconnected thanks to the digitalization. And what we have earlier usually looked at as socio-cultural or socio-physical systems, there is definitely this cyber layer. And this also means that the world is increasingly reliant on the exchange of data. And as many of you probably know, data is considered the new gold or oil, so to say, because data is what our future services are kind of built upon. As we want the future systems not only to be sustainable or good services, but also resilient, we need to keep up with how fast this technology is now evolving. And protecting our data, in that case in the energy field, means that we are also maintaining the energy system in function. And with these words, maybe I made it very clear that it's very important to explore cybersecurity now in the energy system. And Baha will now start with the OT.
All right. Thank you very much, Petra, for the great and very detailed introduction. So yeah, I'm going to start here with the OT. I'm going to start the story with addressing cybersecurity from education, from operational technology perspective. So as you all know, like we're right now transitioning to low carbon future with more renewables and distributed energy resources integrated into the electricity system. The system is now like becoming more digitalized and interconnected, offering great efficiency, flexibility, and resilience. However, we're also knowing that nothing is perfect. Digitalization exposes systems to cybersecurity threats ranging from malicious hacker to state-sponsored actors, and we have already seen it how like they are manipulating the energy systems. Here we're talking about when we're talking about operational technology, we're referring to the use of hardware and software to manage and regulate industrial activities, machines, and devices in different sectors such as energy, which is our concern today. For electricity systems, the combination of sustainable digital technologies and low carbon solutions comes with own unique challenges for operational technology experts that operational technology experts now need to address. Next slide, please. Okay, all right. No, it was all right. All right, okay, yeah. So, for example, I'm gonna give a few examples here. One significant challenge lies in the integration of renewable resources and the management of a diverse energy mix, where specialists need to adapt to the complexities of integrating solar, wind, and other green energy resources into the power grid. This would involve developing and implementing advanced control systems that can efficiently handle fluctuations in renewable energy generation so that we could ensure stability and reliability in the electricity supply. Another concern here also that we need to address is about cybersecurity, as we just mentioned. Since the increased reliance on digital technologies within operational technologies brings all the cyber security challenges and risks. For example, to the more interconnected and data-driven critical infrastructure. Another challenge is about occupations and jobs themselves, and the need for operational technology professionals to continuously enhance their cybersecurity knowledge and skills to develop strategies able to mitigate potential cyber risks and safeguard the integrity of the electricity system efficiently and effectively. So now I would like to start with our guests. I know that this is a complicated matter, but I would first like to ask them, who is responsible for ensuring the cyber resilience of operational technology systems? Is it a person, team, software? Who's actually the future OT expert? And what are their specifics and criteria? Please. Maybe we can start with Ross.
Okay, so the question was, who's responsible? Well, I think we're all collectively responsible, I would say. So it has to come from top down, regulation, and that's what we're seeing now. Regulation's been rolled out. IEC 62443 is a framework. If we stick to those sort of fundamentals, foundational level there, you can't go very wrong. So. But as a responsibility, I would say that we're collectively responsible, and that should come from government.
Any specifics? Any criteria?
What do you mean, sorry?
Any special specifics or criteria for those handling OT?
Well, if you stick to frameworks like IEC 62443, then you can't go too wrong if you're... And also collaborating. So what we do in Wärtsilä a lot, we have, for instance, an OT alliance where we collaborate with a lot of our peers, because collectively it's good to collaborate in these areas. All
right. Hirta, what are your insights?
Well, from the lawyer's perspective, it's very clear that the responsibility is on people, it's not on software. And then when we think about the people who are responsible, I agree that we are all responsible if we can affect the security. And according to the NIS2 directive, for example, the management of the entity is ultimately responsible. So this is very much in line with what was said before. But of course, every employee also needs to follow the instructions and company policies. And in that way, every employee is also responsible.
All right. Olli?
Yeah, I agree that it's team effort. No one individual, no one company can make it work. So the ecosystem as a whole needs to kind of design everything to be secure from start to finish. You can't go to any vendor, any shop and just buy secure system. It must be designed from the start. And it includes people, it includes, of course, the software and hardware also. But regulations are also critical and important thing to help in helping our things to go more, be more secure.
So there would be no panel if we can't spark a debate. So I would like to challenge a little bit what I said before. Isn't it like that when it's a team effort, absolutely no one is responsible? And how will this responsibility look like in this complex energy system that we have? Because of course an individual company has a responsibility, but what about a joint responsibility? Who is ultimately responsible for everything works together? Of course, you have transmission system operators that connect on both consumption and production and storage and sector coupling, etc. But it is very difficult to see for me that even if every single individual has some responsibility, how do we protect ourselves from a coordinated attack against many of these individual and single companies. And I see that there are regulations coming up from the government besides the standard that you mentioned. But for me, it's a little bit challenging to see, and I think that's also one of the reasons that we have this REDISET project. Where are actually the weaknesses in the systems? And one of the things that has become very clear at the workshops that we have, that is the data coming in. If there is no data coming in, we have to shut down the electricity system in seconds, because it maybe 15 minutes becomes too dangerous actually to run it. And I think it's very important to identify the weaknesses in the system, and even if it is a collective responsibility, I think in the end, if we have a major blackout because of cybersecurity, the people or the government want to blame someone, and you can't blame then everyone in a society. So yes, I understand it's a common effort, and I see that, but who is the ultimate responsibility for when a big blackout happens because of a cybersecurity event?
What do you think, Reino?
Well, something I could add for the previous comments is at least that when looking the topic in engineering perspective, the cyber resilience is something that should be taken into account all the way from the early levels of the system architecture design. So if we think, for example, electricity distribution, it should be added to the architecture planning all the way since the beginning. So when we start from the standards and the regulations and go to the actual work plan and the sharing of the duties, it should be there all the way. And if it is done properly in such a way, then also the responsibilities will be divided so that there are certain persons and certain entities who are responsible about certain parts and functionalities of the system, because that's also something which is important. In a practical point of view, it is a collective responsibility. But without indicating and sharing the responsibilities, there is always the risk that shared responsibility means no responsibility.
Exactly.
So somebody needs to look after that.
Yeah, I agree with you. That's good. Well said.
Thank you very much. That was very insightful of you. So now let's explore some more operational technology challenges. For example, in the case of electricity system moving towards the green transition, including wind turbines, solar panels, smart meters, microgrids, and other devices that interact with the physical environment, there should be a team, as we just mentioned here, to monitor, detect, and respond to cyber incidents and attacks on the OT systems. For example, like many scenarios can actually happen here, if the operator receives an alert that a cyber attack is underway, or the attackers, for example, have breached the network of one of the wind farms and are trying to manipulate the control system, or they are attempting to cause physical damage to the turbines by changing their speed and direction. So there would be some sort of disruptions. There are many scenarios we can imagine here, so we need to start thinking how we can defend against them. And here is the question I would like to ask to our panelists. What specific measures and strategies should be undertaken by OT experts to prevent cyber attacks and incidents so that we could ensure the integrity of the energy sector critical infrastructure? Maybe we can start with Reino this time.
Well, that's a very wide question to answer briefly. But what is important is that the most critical points of the system must be identified, protected well with a high priority, maybe multiple protection mechanisms so that if one fails, there would still be another,
layered approach.
Another for that purpose. And one important point is also that the protection should be dynamic in such a way that, as you know, in every area of cybersecurity, there is a continuous competition. The bad side is seeking new methods and new ways how to attack the system. So we need to follow, are we still fully protected? If we are now, we are not necessarily on next year or maybe not even next week. So there should be dynamic follow-up and a capability to adapt to such new risks that may rapidly come out. Also, it is important to have a kind of modular architecture so that if some part of the system, like a certain wind turbine park or a certain wind turbine or substation area or whatever becomes contaminated in such a way that some third party with some negative intentions are in the system, we could rapidly isolate that part from the rest of the network to avoid the spread of the failure there.
Yeah, I think it's like a two-way approach. We know already that cyber attacks on the electrical power system are a fact. They occur very often. We also know as a fact that they actually cause blackouts now and then. And then it's two things. It's like limiting the damage of a successful attack or preventing an attack to happen. But the other thing, as you mentioned already, is that how do we actually fast come back? So we know it happens, we have a blackout, but how do we get then into business again with an attack going on? And there are a few strategies that you can choose. Of course, it's like insulating system and zones that you can have, and of course a manual backup system that is not based so much on IT. But that becomes more and more challenging, actually. And I think it's also aware, and I think the European TSOs are aware of it, is where you purchase your equipment from. So actually you can put evil things in your physical equipment that we need to avoid. So good checking of what it is that you buy, having good overview over your supply chain, what you're actually purchasing and who's manufacturing it. That is, of course, one thing. And then, of course, you come to the whole design of your system with enough redundancy and enough checks that you actually are not vulnerable to cybersecurity attacks.
Yeah, I'm process-oriented person, so I would say that the first thing you need to have is proper documented process you are actually following when you are designing the system. You should not work in ad hoc style, because that will cause troubles. But one other specific thing also is that previously, especially in power grids and industrial business, systems were bought and then they were updated 20 years, 30 years later. But that just don't work anymore. You need to plan that the system will be updatable and upgradable in all the time. Well, not every day, but kind of regularly, because that's the only way to keep things secure.
Hirta, the legal perspective.
Of course, you can take a lot of different measures, and you can also categorize these differently. I think it's very important that you have the operational and organizational and the technical parts to this. And also, as Sonia mentioned, you need to consider how to try to prevent the attacks and incidents, but you can't always prevent them. So what you do, and do you have the processes and policies in place for a case when this does happen? And actually, new legislation even lists many of the measures that the entities in the scope of that legislation should have in place. And these include, for example, training employees and supply security management and many different aspects.
Okay, I would just echo what I said before, which is just implementing a foundational level of cybersecurity related to these frameworks that we're talking about. So you need to have a good basement, a colleague of mine likes to say, which is starting with what assets you actually have. So OT asset management is very important, and you start from there and you build up. And you, like you say, awareness training, starting with people. The human element is one of the most important. You need to do your training, incident response, backup and recovery, documentation. So very sort of the fundamentals. And exactly what Ollie was saying, you need to have good recipes and playbooks in place so people know what they're doing when something does happen. So.
All right. So yeah, as we can see right now, like there are many challenges that we already are facing on the OT sector. So we can actually emphasize two practices. One of them is that we develop skills and promote continuous education. The other practice is actually for companies and organizations like that they promote their employees to be like more expertise in IT and OT at the same time, so we can like tackle both sides when they happen. So right now, actually, like when we started like talking about the IT, let's move to the next part, which is more about the IT. And as we're seeing right now, we're facing a lot of rapid advancements of engineering and introduction of a lot of innovative concepts, techniques, and technologies in the IT field. And the information technology has changed a lot out of this. So for example, we're having right now that the IT in the past was about only certain functionalities, but right now IT is actually almost everything in our lives. So while these technologies improve much services and the quality of our lives, they also introduce new risks. And as we highlighted before, the integration and the increased reliance of the energy system on IT, this also makes it susceptible to a whole can of risks. So now I would like to ask my guests, like maybe to share some insights on the potential risks associated with advanced IT technologies within the energy sector. So maybe you could elaborate on some specific technology you are familiar with and the potential challenges it poses. It's a very wide question.
Okay, yeah. So we were talking about OT, now IT. So OT-IT convergence. Obviously, this is a massive thing now where the lines are getting blurred. People are wanting connections to everything, which obviously interferes with network segmentation, defense in depth, like they were just talking about. But I would probably say one of the most disruptive, I mean, it's a buzzword, disruptive technologies is, you guessed it, like generative AI and AI. So for just creating so much data and nonsense and phishing emails, and that is the main attack vector for most attacks. I don't know the exact number, I would imagine 80% plus of cybersecurity attacks are from someone clicking on something stupid. And now with the sophistication that AI can provide, with people can have correct English, doing all kinds of crazy scams, deep fake technology. You can like have one picture of someone and you can change your face live on a Teams. I could be the CEO of somewhere and ring someone up, change their voice. You need 30 seconds of someone's voice to actually copy their voice now. And these are all open source tools, freely available. So I would say that's one of the biggest.
Yeah, I can add to you what once in one of the companies I worked for, some hacker sent out an email for the fake email address with a name very close to mine. And that meant that people had been contacting me the whole day by SMS, by email, and by phone. Basically, I mean, so I couldn't do what I was supposed to do. So I think this is one concrete example. So if you attack someone, for instance, in a control center, or someone who has a managing function or whatever, if you do that kind of attack, I didn't click on anyone, but the other people went for, you know, for the email, then you basically block out a number of important functions in companies, and by that to disrupt the normal operation. So that's one example that doesn't have so much with OT to do, but I mean it has to do with the other one. And the other thing, that example is the very famous attacks in Ukraine that went via the administrative system. They were planned 2 years ahead of the final attack. So we see that the attackers also have a lot of patience. So they go first to the administrative people, to the and the administrative functions, and then slowly get their way into the system for them to final attack the operation and shut down the whole power system. So I think we have seen real life examples already.
Yeah, open source intelligence, people just looking through LinkedIn, looking for faces that look gullible, you know, and phoning them up and stuff.
All right. Want to add something, Rino?
Well, one fundamental issue is that with so-called smart grid and green transition, the energy production is becoming more and more distributed. And to be able to integrate the distributed production to the whole power system, we also need more distributed automation. And to enable the more distributed automation, we need communication for that. And all this, well, it creates a lot of opportunities, and that's the way of the future. That's something we all know. But it also creates a lot of new risks in terms of security. So how to handle the communication, how to handle the distributed devices there. So one particular issue is that right now there is a kind of hype, well, it has been already there for a while, for cloud computation and cloud services. And yes, it is very handy practice that we collect the information to the cloud, perform the computation there, and then provide whatever control or result signals we want back. What if we lose the connection to the cloud?
Yeah.
What if the cloud is disconnected, or what if the cloud is somehow malfunctioning? What kind of backup do we have? Or do we have a backup? Can we rely on the cloud connection there? Would our system have a capability to alternate between cloud and some kind of distributed edge computation? If we have the edge computation, how to make it robust? Those are questions that we need to think about. Then another particular risk that was already referred was that we may have new so-called intelligent devices, and it should be automated how those devices can join and leave the network. And we need to be careful with the handshakes. On the other hand, it is needed, but on the other hand, it also forms a risk because we may have a device set by some third party which is intelligent, but with bad intentions, so that the device joins to the network, learns for a while, starts a little malfunctioning, and before the network security notices that there is something wrong, there is already a big damage going on in the energy system. How to avoid that and how to protect ourselves from that would be one big challenge, because that's one of the places where the sophisticated AI will make such devices better, and that may happen even relatively fast.
Yeah, and I think that is a really challenge because we can't run the electricity system anymore without AI. There is already for 40 years AI is being used in the electricity system, and then we can't run it because it's so complex without AI. But on the other hand, it's very vulnerable because without data we can't run it, and without good AI we can't run it. And there's also a risk, as you said, that the more and more we automate, the less people we have available. And in case of a big damage, you actually need these people to be local. And there's also a question about, how many people should you have available for contingencies? How much money is that allowed to cost versus the amount of time that you actually need them? And how do you train them when you seldom have manual operation? So I think that's also some organizational challenges and financial challenges.
Maybe I would move right now with my next question. So actually, I would like to ask this time, like Olli and Herta. Like right now, like we have addressed like the challenges of OT, but right now we can also like want to see what are the opportunities. So what are the opportunities and benefits of such a transformative landscape it brings to the energy system? How the IT integration can revolutionize our energy system, foster resilience, efficiency, and sustainability for a brighter future. Also, what might be some of the unwanted side effects?
I think this is more of a technological question, so I think I'll leave this to my more technology background.
Yeah, there has been quite much speak and discussion about IT-OT convergence, but I see that a bit risky thing, because the fundamental design criteria for IT systems, they are totally different than the same criteria for OT systems. In IT world, you want to have privacy, you want to have confidentiality, but when you are going for OT side, there are safety, reliability, availability. And if you want to manage OT systems the same way you manage IT systems, it will fail, and it will fail fast. So if we want to integrate them, there must be really lots of discussion between IT and OT experts. So how to actually make it happen, how the system should be and could be connected to each other. And how to actually make it work well. Because if we take IT approach and apply it to OT side, it won't work. But on the other hand, if we take OT approach and apply that to IT side, it won't work. So that's one thing which is really important to understand from, I think.
So we cannot ever have like a one seamless like system IT OT. Just
I don't see that possible.
I was betting on that we can.
No, but I mean, if the role for IT and the energy transition, I don't think the energy transition is possible without the use of IT. I think that's a fact that we have. On the one hand, we see also that the use of IT increases the use of energy. So we have to make sure that the systems we use also are energy efficient. But the energy transition without IT, it's not possible.
All right. Anything that Ross or Reno want to add?
Well, we already see the effects of more sustainable energy production during the latest 2 years, for example, when you have been following the green production of electricity, there has been amazing results time to time. But on the other hand, there are also new ethical and legal questions. For example, the planning of the wind parks, the wind turbine sites. There has been a lot of arguing and legal hassles related to them. Some of them reasonable, some of them somehow mumbo jumbo, but in any case, there are issues that need to be handled in a legal point of view. And one particular thing that could offer some interesting new opportunities where IT is also needed is first the use of local electricity production. In a case if we have a blackout in the trunk network or somehow incomplete capacity of electricity. Then another one which is still maybe in more early levels, but what would be very interesting and also very important is that what could we do if we have such a situation where we can offer, say, 30%, for example, of the capacity which is required? How to automatically direct the electricity there where it is needed? There are the critical targets, hospitals, people's shelters, etc. Yes, they have backup power, but not all of them. And if we go to the shelters, for example, in some of them the backup power is up to date. In some of them it is not. And if you think the technological part, we would already have all the pieces of the puzzle, all the way from the upper levels to the automated fuse centers at homes. The question remaining is that how to put them work together in a proper way. And actually the same solution could help the so-called use of green electricity as a marketing purposes, even a more advanced way what it is done right now. This is something that, for example, in the military side, there is a lot of interests to this topic based on the recent observations done from the war in Ukraine and so on.
All right. So yeah, I think I'm running out of my own time here, so I might stop here. I still have actually had another question, but I will leave it like for some other time. So thank you very much, guys. I always appreciate it, and it's always I learn so much from discussing with you. And here, as we have only heard and learned about the beginning of the story, we're gonna move to a central piece of this puzzle, and I'm gonna handing the mic to my colleague Linda and letting her introduce you to the complexities of policy and law. Welcome, Linda.
Yes, thank you. So let's put on the next slide. Also next. Yes. All right. So it should be clear by now that we need to add a new part, namely the cyber layer, when we are addressing the traditional socio-technical system of energy. So, reports show that cyber attacks are increasing significantly, and even though the public administrative sector is still the most targeted, the energy sector is also rising. And what is considered to be quite interesting is that the energy sector is often targeted from the supply chain. So the cyber attacks, they have expanded during the last years, especially as the digital leap happened during COVID-19 and the Ukraine crisis happened. And they brought new cybersecurity challenges, I might say. But yeah, this has been also recognized by the European Union. We can put on the next slide. So they decided to revise their network and information directive to address these threats. So its scope has expanded. And compared to NIS1, NIS2 broadens its reach. So it includes more sectors and companies. It aims to bolster security and reporting protocols and foster collaboration on the cyber threats and crisis management throughout the EU. The energy sector operators are identified as essential entities, so they are facing stricter penalties under the new directive. Notably, the scope of incident reporting has also been expanded to encompass third-party suppliers as well. So let's put on the next slide. Yeah, so I figured I might ask always Hertta's, the lawyer's perspective, and then pick out one of you to give like a technical perspective. Would that be all right?
Yes.
Yes? So, how do you think that the inclusion of third parties in incident reporting due to the expanded consideration of the supply chain in NIS2 will impact the safety of energy sector?
Yeah, well, first of all, some of the third parties are in the scope of the NIS2 already, and so they are required by law to report some incidents to their clients and to the authorities. But not all suppliers are in the scope. And then it's very important for the energy sector entities that the energy sector entities require that their suppliers are bound by these reporting requirements, for example, towards the energy sector company in question by agreements. Because otherwise, it's not necessary so that the supplier will report without undue delay to the energy sector company.
All right. Reino, could you maybe comment on this? Do you have any insights?
Well, what I was thinking briefly related to this question, the exchange of the sensitive information should follow the same principle what is used, for example, when the public authorities like police or security officials change information inside EU and between countries. There is a created practice for that. And suitable rules from the same practice could be applied for this sort of exchanging of information, sensitive information. Yeah. You know, you're more precise because you know the legal side.
But that was very good perspective.
Okay, so I've read somewhere that Finland reports most of the incidents, but could the differences in how much countries report the cyber incidents lead to some countries being safer and some then riskier over time when we consider the security of energy sector?
I don't think it directly affects it like that. But of course, if some countries report too little, then it raises the question, is everything reported? And this is, of course, affecting the safety if entities and other countries do not become aware of the vulnerabilities or incidents. And on the other hand, too much reporting is, of course, very burdensome to the entities and also to the authorities. And maybe it could be harder to follow all the information if it's too much of it. Mm-hmm. But we must remember that also already this NIS1 directive included some reporting obligations in the energy sector, for example. So it seems that there were no major problems because of this. And maybe I would also add that this NIS2 sets quite strict minimum harmonization. So countries cannot vary that much in how they implement the directive.
All right. Maybe Sonia, would you like to add something?
Well, as with every technology, there is a plus and a minus. And with every law, there is a plus and a minus. So Of course, there will be differences in reporting because we see that it's something that's also based in our culture. But I think in overall, I think we can learn a lot from it. And we know, for instance, if you look down on the TSO or on the DSO level, there is a big difference in digital maturity between the different organizations and companies out there. And I think that, let's say, the more mature organizations can help the less mature organizations in actually being prepared for the cyber attacks and know that this exists. But with every information exchange, there is always a risk that the information is leaked to some party. So I think that's with everything. I think there's pluses and minuses. But I think regarding this, there is more pluses than minuses because the people that are attacking, they know very well what they're doing. They have so much knowledge, they don't need to go into this database and look. So I think the most dangerous attackers, they will not benefit from this. I think it will be the lower educated attackers that maybe benefit from this.
So the most bad guys won't benefit, I guess.
That's my idea. I don't know, a hypothesis.
Let's hope
until
we will go
someone
that
proves
way.
otherwise.
Okay. When we are reporting cybersecurity problems, it also reveals sort of like the weaknesses that operators have. So one might think that some people, let's say the criminals, might use this information for harmful purposes. So could the reporting actually pose a threat to the electricity sector or energy sector? What do you think, Herta?
Well, at least this NIS1 reporting hasn't apparently caused any major problems. Maybe it's because of this that the attackers don't need these reports. But of course, we can't say that these disclosed information about the attacks don't inspire someone. Of course, that's possible. Yeah, but I don't think it's a major problem. But of course, also not everything needs to be disclosed. So you need to do it in a smart way and only disclose what needs to be disclosed.
Mm-hmm. Okay, Ross, I know you're a science fiction fan, so could someone be inspired?
Yeah, maybe. I find this interesting because, especially from this too, if you look at the SBOM area, software bill of materials, so this is like, you can actually use this as kind of like a license to sell, so cyber. So you can, with the software bill of materials, you have to track all the packages. So you might have been familiar with the SolarWinds attack, which was a supply chain attack, which opened a lot of people's eyes into what a nation state can do if they get into the actual updating of software packages and put malicious software in there. So off the back of that, it's been stated, especially in the US as well, Biden said that, you know, this is one of his main things around SBOM, is that you have to report when there's a vulnerability within a certain amount of time. So from that, you can actually get statistics on how good your code is by how quickly you update the packages, etc. So you'll be able to get a metric on how well a company is managing its supply chain, for example, its packages. So.
Okay, shall we put on the next slide? So yeah, you kind of addressed also the SBOM, software bill of materials, and now I'm talking about the Cyber Resilience Act, which is like very much something to do with that. Okay, so yeah, so as Ross mentioned, the Cyber Resilience Act, it aims to make all digital products, like let's say phones, factory machines, safer in the EU. So it requires the producers of these products to protect data and fight off cyber attacks. And they might, maybe if they don't follow this, they might face big fines. However, the goal is to ensure that digital products are safe from the beginning and stay safe. So ultimately, it's making people trust the digital world more, let's hope. However, both NIS2 and the CRA, so Cyber Resilience Act, work towards protecting data and system from risks. So as Ross mentioned, digital products are made more secure by, for instance, providing the list of ingredients. Now this means the software bill of material. And this list will be required for all EU products latest 2027. So let's put on the next slide. Yeah, okay, so as we move forward towards the future where operators are required to share these SBOMs, is there a concern that we might be disclosing too much information, especially when operators have to share these details with customers? What do you think, Herta?
Yeah, there is a risk because you can share what you want. So basically, you should think about what is smart to disclose. You don't want to disclose your trade secrets. They are not trade secrets then anymore. And also, you want to only disclose the relevant data. So yeah, it's a risk if you don't do it in a smart way.
Mm-hmm. Olli, do you have something to add here?
From technical point of view, there are kind of two aspects, and they are related to what Herta mentioned about what you should disclose and share. So one way to build the SBOM is to take the binary, the software you already share with customers, and put that through some number crunching machine to get the SBOM. So if you do that and publish results from that, I don't see how that would reveal too much information, because anyone who owns the software, who has the executables, they can do the same exercise. But then if you start to include that level of information which is available before you build the software, then it becomes a bit more critical regarding the IPR and trade secrets.
Mm-hmm. Okay. How does this balance with the need to protect intellectual property rights, like particularly in cases where operators use open source code?
Yeah, I think this is quite similar to what was already said, that you don't want to draft them in a too detailed form to balance the transparency and the IPR. Yeah.
Does anyone from our technical side have anything to add? Well, someone's going to have to. Olli.
No.
Okay.
I already said what I had in mind.
All right. Okay. Yeah, my questions are over, so I'm handing the mic over to Petra. So as we know, the legislation sort of follows how fast the technical improvements happen, but the legislation and policies, they are made to shield the human in our society. So Petra will now continue.
Hello. Yep. So last but not least, the social-cultural perspective, and this is created with AI. I asked for a sustainable society. So there you go. Next slide, please. Oh, actually, go one back maybe. Yeah. So I think we all know by now that energy and especially electricity drives the society, which means that our modern lives are not really going to continue without the constant need that we constantly have energy. We are more and more vulnerable to natural or human-made disasters and attacks. And we know already, as we heard, that some of these cyber attacks, especially cyber warfare, aims to create chaos by destabilizing critical societal functions. In case of major blackout, for example, most societal functions would have stopped within the first 15 minutes. And in 3 days, depending a little bit where you live, there might be complete chaos. We were actually having this discussion last week in Stockholm and Oslo, and somehow it seems in the Nordic in 3 days we would still somehow manage, but that's about the general idea. Research shows that, or you hear it a lot or read it a lot, that it is not the physical infrastructure that is the most challenging part of when you're constructing a smart grid, but rather the ability to provide security and privacy. And I think we have heard it here as well. So the human factor is really argued to be the most central when we are ensuring the progress of a safe and resilient cybersecurity culture. So we're talking a lot about this cybersecurity culture. And if I give you some examples of types of cyber attacks which are targeted directly on people, there is manipulation, sabotage, and espionage. And these types of attacks might include energy theft. That's quite typical, actually. Somebody steals half of your electricity from your smart meter. False data injection and leakage of customer information. So privacy issues in smart grids are an emerging problem. And they collect a vast amount of data of energy usage, which includes your personal information, such as location, habits, and preferences. So that's like direct insight in your daily habits and routines. So this is kind of raising interesting questions regarding rights and responsibilities in the energy sector. And we would start with with the first question. Thank you, Linda. So by digitalization, people are increasingly interconnected. And in this context of cybersecurity, it is often heard that humans are considered the weakest link as well as the shield. So what do you panelists think about this claim? Any particular risky or vulnerable users? And who is actually responsible to protect and shield them and the system? I think I'm going to jump and start with Sonja.
I think it's an excellent question because, I mean, we know from experience that it's all the IT and OT we can test and validate. There are systems in place and companies who perform such checks. But we know also that the humans are the one that are, as you mentioned, clicking on the wrong links, and they are becoming better and better, so it's more and more difficult to see it. Yeah, we need to educate the people in the companies and also in the general public. What does a cyber attack look like, and how you can prevent yourself from that. But on the other hand, if something is going very strange, you also need the humans in the loop to identify that one. And I can give, even if it was not a cyber attack, I can give this example from Finland, that some company made a bid, a wrong bid, because they put a zero in the wrong place in the market, and then the prices in Finland went very negative. I mean, if there would have been a human in the loop, they would have discovered that there was something very wrong, and there were humans in the loop, and that some event like that might have been prevented. So yes, they are both the weakest point, but on the other hand, they can also be actually the ones that identify an attack and can, help us to counter-work it.
Thank you, Sonja. Olli, what do you think? And do you have any good examples of who are really risky and vulnerable users?
Let's put that way, that if you rely that every human, every employee works perfectly in all cases, does not make mistakes, and your security of your system is relying on that, then your security is broken. Humans make errors. That's the way I see it. So no one action should cause, no one action from any employee should cause that the whole system is broken or breached.
All right. Yeah. Hertta, what do you think? Have any suggestions?
Yeah, well, I agree that humans can be the shield because humans make the decisions at the end of the day about the security measures that are taken. And also they can be the weakest link, of course, when they make errors or accidents or something like that. So there is the responsibility on the people to shield their systems and their entities' systems. And this can be on the management or on the employees or on private persons to some extent when it comes to their own systems. But of course, there is also the criminal liability of the attacker. You can't use a vulnerability and make a data breach. Of course, that's also criminal. So there's this side to this responsibility as well.
All right, thank you. Ross, do you have something to say?
Yeah, I would echo again that you start with this sort of foundational level of cybersecurity for your employees anyway, and create a journey for them that they go through And the end of that journey is that you're enabled as a cyber citizen. You know, everyone's part of the cybersecurity team, and that you're enabling this by teaching each other and sharing. And we've got to remember that our personal life and work life bleed into each other now. So these secure behaviors that we learn in work also transmit to our daily life. So it's really important. And I think there's an EU project at the minute around cyber citizenship, if you Google it, which is all about this. And it's about us helping each other and raising our cyber resilience, because we're all part of the cyber team. You know.
Yeah, that sounds like a hopeless project. Sorry to say, but
Hope.
but yes,
Really?
thank you. We can discuss it more. Reino, do you?
Yeah, we should just ignore it all. Yeah.
Well, the human factor is always there. So it can be a benefit, but it can be a risk. And like it was said in the previous comments, sharing is important because all the wisdom is never in one head. There might be an error done in the practical level during the action, or there might be a human error which is already done when planning the algorithms that are looking after the security. So for both reasons, it is continuously good to share the information so that there is a kind of dynamic follow-up going on. When thinking about the responsibilities, it can be somehow parallel when thinking about the electric safety. The company that plans the system, makes the installation work, is responsible about planning and installing a safe system. Then they provide instructions for the owner and user that use it this and this and this way, don't do this and this and this, to do it in a safe way. That same principle can be easily be extended to cybersecurity as well. And then the people who either because they are careless or for in purpose violate those rules are the ones who are usually causing the biggest risk. Another particular thing I would like to point out is the marketing, because once we are able to collect more and more data from different parts of the system, and we have more and more sophisticated methods to utilize that data, there is also a big interest to collect all kind of data about customer behavior for target marketing and customer profiling purposes. And there, the principle that we only collect the information which is needed for system safety and system use should be respected in a critical parts of the system. Even though there would be a lot of nice to know information for marketing purposes, collecting too much information and sharing it for, how to say, such an entities which are not required for the system use may form an additional risk, and that risk may grow relatively serious over the time.
A lot of the problem with that, though, is that a lot of these, like Google, etc., is built on data and getting all this information in order to profile people to sell more rubbish.
Yes, because that's where the money is.
Yeah, that's where the money is. So to move away from that model would be good.
Yeah, and there is a public regulation needed for that.
Just a race to the bottom, isn't it?
Yeah, and of course there is already some public regulations like GDPR.
In Europe, yeah.
Yep.
Yeah.
Thank you. We're really I think we're almost answering the next question as well already, but let's continue a little bit. Yeah, as you can, sorry for my negative comments in between, we can discuss it later. But there are very much levels to this idea of cybersecurity, and especially when it comes to humans, and now we are listening to more of a maybe abstract level of all these different ingredients in the market right now. If we dive a little bit deeper, there's something quite specific, there's a quite specific way of doing cyber attacks, which is to humans, which is called social engineering in cybersecurity. And in the context, it means that it is a type of attack wherein attackers exploit human vulnerabilities by means of social interaction to breach cybersecurity, with or without the use of technical means and technical vulnerabilities. So that means these vulnerabilities can stem from aspects of psychology, cognition, consciousness, thought, behavioral habit, neural reflexes, and so on. And then there's another research or article that was looking at this security awareness and competency in Europe and in some energy companies. And they found that many employees lack the skills necessary to transform their security awareness into security behavior and competency. So this is a challenge. And that there is a lot more needed to work with this workforce that they could secure the critical infrastructure of the energy sector from this kind of unintentional insider threats. So if we take that one. So it seems that social engineering affects everyone by now, somehow, at some point, some level. And it is definitely something that needs to be handled inside the organizations. And we also already discussed that the human factor is actually quite hard to handle. Maybe you can give us an example of some kind of social engineering attack you know of, or maybe something you have heard about. And what is done to prevent these occurrences? I know we were already tackling this issue of cybersecurity inside organizations, but maybe would you like to give some more insights? Ross looks like he wants to.
Well, there was an incident last month, wasn't there, in Hong Kong, where a CFO was tricked into giving up, what was it, 500,000 or $1 million by a deepfake video. So he was phoned up, like I was talking, he was phoned up by the CEO and told him to transfer some money, and he did it. So that's something we need to, especially we're making our employees in Wärtsilä especially aware of this, and we've been holding webinars doing deepfake technology, for example, and showing that how easy it is. And always, like, if someone contacts you, always back it up with a second method, you know, even if it's their voice or video, you can't trust. If it's something unusual that they're asking, always, like, confirm it through another method. You know, don't take their word for it. Always use this sort of two-factor authentication, you know.
That's quite a lot of money.
Yeah, it was in Hong Kong. Yeah, it's quite crazy. Yeah.
Oh.
I actually found, when researching, I found that there has been at least one publicly reported case where social engineering has affected actually the real steel mill. So this happened in Germany in 2014, and I read from the official report. The attackers used spear phishing emails in tandem with sophisticated social engineering to gain initial access to the steel mill's office network. From there, they worked their way progressively into the production networks. Breakdowns of individual control components or entire installations increased. The breakdowns led to the uncontrolled shutdown of a blast furnace, leaving it in an undefined state and resulting in massive damage. So that's the reason why the IT-OT convergence can be a bit risky. The attacker got in via social engineering to office network, and they were able to break the steel mill, part of the steel mill.
Thank you. Hertta, you're in the middle of the two guys talking, so would you like to continue? Do you have some examples, or do you prefer to jump over this?
Yeah, I can. When we discuss about ways to try to prevent, again, these social engineering attacks, we can talk about training and so on, but also, again, we need to figure out how to mitigate the risks if these kind of social engineering accidents happen. So do you, for example, know where you have your data? Do you know that if this system gets breached into, what dependencies there are? Also, when it comes to one person's ability to cause damage, I think you should try to mitigate that. So, for example, you can have processes where multiple people need to be involved, or access rights are limited, and so on. So there are many ways to look into the risk mitigation also.
Okay, thank you. Maybe Sonia wants to continue?
No, I think just to come back to your earlier comment, we learned people not to put their fingers in the electricity plug. So I think there is a chance that we actually can educate people on cybersecurity. And I think Nowadays, the companies are having a lot of awareness and training their employees into that. I think it's just a matter of time before it comes into the school curriculum also.
Definitely.
So I think this will be integrated in education at the end, and I think it has to be, because if we can't mitigate everything, and else the risk for the society becomes too big. So I think here also the education system has to step up.
And I think that even going further than that, I think behaviors in school, like mindfulness,
Yes.
should be taught in school, you know, and just like pausing for a second and thinking before you click an email or before you act. I think it's a really important skill that we should all have, and all sort of take a breath before we act.
That's very good insights. Thank you. Reino.
Well, a friend of mine who is working as a head of security in the organization, having a size of about 2,000 employees, told me there is one people from the senior staff, one of the highest paid there. So somebody who was a native Finnish speaker, speaking good Finnish, gave a call to the payroll department that, hey, I'm this and that guy, and I just updated my bank account. So could you please update my bank account number to the system? And the one who received that request was saying that, sure, we can do it, but for some reason she did not have time for that right away. So she wrote the new bank account number down to the post-it sticker and gave it to the next employee who came there. And the next employee, just to be sure, because the number was handwritten, gave a call to that guy that I just wanted to check that is this your new bank account number right? And the other one was wondering that, what are you talking about? What a new bank account number? So it was pretty well planned. They knew that that guy was one of the highest paid in the organization. Also, they knew that if you are a member of the senior staff, then they may easily say in the payroll department that, okay, we can take care of that. For someone else like me, they may say that, why don't you log in and do it by yourself?
There's a great book to read, Art of Deception. Have you read this? Art of Deception.
Yeah.
It's like this, same as this.
And then there was another human factor, just as a coincidence, that the other one, since he wasn't sure about that, did he read the handwritten number correctly, wanted to double check. So after that, they updated the instructions so that every time if somebody wants to update something like that, make the double check without making any changes. So there will be more and more this sort of actions in the future. Quite simple, but on the same time, it was utilizing the human factor quite clever way.
There's a great book, Art of Deception, by Kevin Mitnick. He died last year, I think, but it's really good. It's all about social engineering, going from the 70s with computers. It's a really great book about social engineering.
But I think also the example you gave is an excellent example about how humans can be the shield and how they can be the weakest link.
Yep.
And he talks about that in the book. He's about, if you understand the processes that people do, then you can...
I think there is actually a process, it's called STAR, I don't know like the rest of it, but it is ST, stop, think.
Yeah.
So just like, it is about like, if you don't take the action immediately, just like stop for a second and start thinking about, okay, like what's behind this thing, like if there is bad intention or something, then you start realizing like, what's going on. But the point is just like to not act impulsively.
Yes, thank you very much for your insights. I think this makes it so visible how difficult it is to be a human in a technological society, because one day you're tired, the next day you're more alert, one day you think about something else, and all this time you should be kind of able to function with the requirements of the system, which is developing all the time. And that's also why it's super important to have this social, cultural, and human behavioral understanding while we are even looking at a huge system, a shift like the energy system. Now I'm gonna say a few things about one thing, and then there's the last question. So don't despair. I'm very proud of you people still here listening to us, because I know this is quite heavy information. There's a lot to cover. So I just would like to give examples of the most known ways to sabotage an energy system. And we can divide cyber attacks into different categories according to the types or motives of attacks. So hacktivism is defined as the use of hacking for political propaganda, protest, or personal objectives, such as fun or self-proving. Then again, cyberespionage, on the other hand, is a strategy aimed at obtaining critical governmental or corporate information by infiltrating computer networks and systems. Then we have cybercrime, which is characterized by the motivation of economic gain through illegal penetration of computer networks, and it's typically non-violent in nature. It just steals all your money. Cyber warfare, consists of actions undertaken by a nation state to penetrate another nation's computers or networks with the intention of causing damage or disruptions, even blackouts. And lastly, and very interestingly, there is this kind of cyber revenge, where the motives of the attacker might be personal, such as getting even with the former employer. Be aware. So putting all this together, what we have been learning today, people are becoming more aware of cyber threats. We have new stricter legislation. There is a lot of discussions regarding fake news and disinformation, and nations are developing ways to counteract cyber threats. What do you think? Like honestly think. Are we on the road towards an Orwellian surveillance dystopia? Or are we creating a more prosperous and sustainable world for all? Reino.
Well, there are threats and opportunities both. And I think two principles that should be followed and respected. One is that we already discussed, that in principle only the information which is needed should be collected. If there is more information just for fun or for secondary purposes, that would always increase the risk of the misuse of the information. And then another one is that in principle it should go in such a way that customer owns his data. Our medical data, as well as the data of the systems we own, should be owned by the customer so that he has a right to decide what he is and what he is not willing to share. Of course, the public authorities have certain rights to see our data, but that's something which is based on the legislation. And then there is a challenge that both of these principles are on the same time conflicting with the commercial interests, because of course the more information you have, the more sophisticated business models you can build on top of those ones.
So which way do you think it's going?
That's hard to say. I would say that there would be both good and bad phenomena.
So you're in the middle right now, you don't know which side it's swaying.
In the middle. It depends on the case.
Okay, what about Sonia? Where is your world kind of headed?
I know for a fact that energy transition isn't possible without large IT innovation that we're doing. So without this energy transition, we end up having a very bad climate and more droughts and or hurricanes and stuff like that. So I think we need to do really this energy transition, and we don't have any other choice right now than using a lot of IT. And I think we need to do then our best to prevent that the data is being misused and that cyber attacks actually happen. And I see there is a lot of focus on let's say personal data, but I don't see that the risk is really there, because I know, for instance, if you would attack attack the weather data and give malicious weather data to all the TSOs in Europe, that will have a much bigger effect on the energy system than your personal data being used for something. So I think we have to distinguish between, and I think that we're doing in this REDISET project, identify the areas which actually have the biggest impact, and these areas might be the areas where we maybe don't talk about, because how many people know that there's just 2 weather models in the whole world, and if you attack one of them, you attack actually the whole energy system. And I think that is a much bigger threat than your personal data being used to see if you're at home, yes or no. And that has to do with the consequences of the attack and how to mitigate them. of course. But I think I think this REDISET project is really good to identify where are the largest risks, because we can't do this without IT. And I'm not so very worried that all this data is used for surveillance, not at all, because it's so much data, it's impossible, and I don't think there is so much commercial interest actually to look at all this data. So I'm actually quite positive.
Okay, thank you. What about Olli? Where do you land?
I'm a technology enthusiast, I would say. So I'm positive in a sense, but then also I see threats. Artificial general intelligence, whatever the AGI term refers, it's scary. But on the other hand, I hope that we will manage to somehow go forward nicely. So I'm positive.
Be smarter than the computers, right? Yeah.
Okay, thank you. What about Hertta?
Yeah, it's true that we have more and more technology and measures to collect data and to survey people. But so we also have more and more legislation to kind of protect our privacy and to get the ownership of our data to us and to limit the abilities of, for example, artificial intelligence. So I'm also hopeful, but let's see.
So hopeful but skeptic.
Yeah.
Ross?
Yeah, so I would say that there's a multitude of different sort of very scary scenarios which seem to be on the horizon. So I don't know which one will play out. It seems to depend on what the current thing is. But like AGI is a big worry. Yeah, we're basically creating a potential alien entity that we don't understand or can control. So I think that's somewhere where we do need definite regulation, and we really need to think about what we're doing in that regard. And then climate change and et cetera. There's a lot of things on the horizon, but I think that we just need to try and collaborate more and try and understand each other better to try and make sense of a very confusing world.
So where are you right now? Like more like middle or?
I enjoy my personal life. I have a nice life in Finland, but if I look at the news and things, I would probably say we're living in some kind of horrific dystopia.
Thank you. As you can see, we have varied opinions about...
But not from what I see outside and all these lovely people and everything. But if I'm to listen to the news and read what's going on around the world, it's pretty horrendous, I would say. So.
Yes. Thank you. As you can hear, there's a lot of different opinions about what's happening, and that's the end of our story. It's been a long story, and I'm very happy to see we still have so many people here. We have some time now to take questions, and you have quite a lot to choose from now, so take your chance if you would like to ask one or all of the panel for some more specifics. And I think Mansi will check if there has been some questions on the chat as well. But maybe, does anybody have something you would like to ask?
Yes, please. Yeah.
As a question for Olli. From telecommunications, I have the experience that there's a big resilience to take in new systems because they think, okay, the one that we have is working and fine, which can lead to the problem that, okay, security level goes down, or then once they have to update, it's a big bang, and then there's more risk. Do you see similar kinds of things in the energy sector as well?
Yes, how to manage updates and everything, it's always a problem. Because it's always risky. You have working system and you update it, something may break. But I would want to see it in a way that we should kind of plan that something may break and it will be fixed. So the updates, upgrades, they are planned, they will happen regularly, and we will kind of expect that something will happen, and then it will be fixed. Because and the more we update and the more often we update, the updates are smaller. So the steps are smaller, and the risk is also smaller. If we update every 5 years, the step is huge, and definitely, most probably something will break. But if we'll update, for example, every 3 months, the steps are much smaller, and if something goes wrong, it's much easier to do rollback and investigate.
How to ensure that that's going to happen?
That's a really good question, how we would and how we should do it. It should be, it's kind of mindset, I would say, and that's something which should be somehow managed. But how to convince also the C-level executives that it should be done, and everybody, I don't know.
I think assessing criticality as well, isn't it, of your assets. So you need network segmentation in OT environments. And obviously you can sort of isolate devices so they're not contacting or not so susceptible to vulnerabilities.
Yeah, and maybe about motivating the management of the company. Now with the NIS2 directive, the management has more responsibility about the cybersecurity in all the entity. So maybe that's that, and the penalties, administrative fines that are in the directive, maybe that's something that you can tell them.
Yeah, and of course there are also more services being deployed by companies that can help actually to before you start to upgrade, to check what's going to happen. You can do this in test environments and laboratory environments, and so more and more tools are coming up to do actually this kind of testing before you implement the upgrade.
Well, regarding the testing, one saying in IT world is that we all have test environments, and if you are lucky, you have a different production environment.
But also there's more and more Windows machines now in OT environments, and the lifespan, unless you've got some kind of long-term service branch, but it's like, what, 5 years, 6 years, you know, Windows, so you're...
All right, Linda, there. You.
Hi, so I guess this is a question for all of you, and I just want to preface this by mentioning I work for a cybersecurity awareness company, so I may be a bit biased on this. But so the company I work for, we very much believe in ongoing training for employees. Everyone needs customized training because everyone has a different level, everyone has their own roles, everyone has their own language that they speak. So one of the things is that the training really has to be personalized to the user. And oftentimes the companies that we worked with prior, they had a bit of, let's say, compliance box ticking exercises. One type of cybersecurity training that the employees do once a year. But looking at this, it may not really be enough, thinking of these social engineering attacks, QR code phishing, generative AI, and Ross, as you mentioned, of course, about 80% of the threats are coming from clicking on phishing emails or so on. So without being too long-winded, how would you guys go about, let's say, creating a culture of awareness? How would you educate employees about these risks without being too intrusive and, for example, forcing them to watch 10 minutes of video on GDPR requirements, for example?
First of all, any training is better than no training. So, of course, training once a year is better than no training. And it is also, in my opinion, it depends very much. If you can also overtrain and people get tired and don't take it serious. So you need to find this balance between zero training and too much training. So I think it's that. But as I said, it has to become a part of our culture, and that has to start somewhere. It's to many people a new technology. For in the energy sector, this has been used for 40 years. So I think this is, or over 40 years, this is no discussion at all. But I think it is the new people that are coming in. You need to make them more and more aware, but also the people that are working, but maybe a little bit older technologies. It should be a part of introducing new technologies in a company. And then if it should be on individual level, that can be discussed, but definitely on role level, because the people have different roles, which are then maybe zoned, and shielded, as you mentioned. That's one of the things important. So I don't know if that's an answer to your question, but I think it's important. It has to be. It's like traffic rules. I mean, everyone has to know the traffic rules. This is digital traffic rules. Everyone needs to know the digital traffic rules. But because of this AI, it becomes more and more difficult to distinguish if it's a real car coming or if it's an AI-simulated hologram car coming. But this has to be part of the training.
One thing which I find really important in all of the training is that you should use more carrot and not stick. So a concrete example is that some companies are using those phishing email tests. You get the phishing email every now and then, and if you click the link, what happens? And so it's test email, so it's not real phishing email. But some companies, unfortunately, if you click the link, they will force you to go through some mandatory kind of punishment level training, and it's not. I don't think it's good. So you should handle it more like, okay, great, you reported this as a phishing email, and kind of give rewards for those who report and do not punish those who unfortunately click the link. Because one example about the clicking the links, I saw some post somewhere on the internet a couple of weeks ago that one person has actually tested these phishing email things. He wrote email to his company which basically said, you should not click this link, this is phishing email, never click this link, just delete it. And I can't remember, was it 5% of employees?
5 or 10% typically clicks.
Yeah. There was a competitor of yours actually, Oliver. They had a marketing campaign where they had a QR code and said, do not scan this. And people were scanning it, and it's but people were scanning. I think they had some stats on it also. But anyway, to echo yours, so October is Cybersecurity Awareness Month, and every year we do different campaigns, etc., and raising awareness. And we've been on like a 4-year journey now. And last year we had a survey, and we were asking this exact question: what do you think to this end? What would actually encourage you to be more cyber aware or sharing? So we had quite a good response. And one of the top thing that they wanted was real-life examples of actual cyber attacks that go on internally in the company. So off the back of that, we've only done 2 sessions now. We created like a initiative called Cyber Bites, spelled BYTES. So it's like 15 minutes where we actually do an interview with one of the analysts who was dealing with something and go through. The first one was about spear phishing, like what is it? And then the second one we did like romance scams because it was February the 14th. So, and then the next one we're doing is about removable drives and safety around that. But we found like a good response to that because it's like bite size. It's 15 minutes and you can watch it during your coffee. And it's real, so it's something that's tangible. So I think that's a good way to engage that we've found anyway. So.
Creating a kind of training culture in the company would be important, and then when it comes to motivation and everything, that's a continuous challenge in all the education. Bigger companies, they have their own educators for that purpose. The smaller ones, maybe they want to buy that service from some trusted source. And then you need to look a little bit around and benchmark and hear the feedback from your own people, but also from some others, that which one seems to be a motivating way and which one seems to be the less motivating one. That's something that needs to be continuously followed.
And you can monitor your employees' behavior with EDR now. So if they're doing something dubious, like joining a Wi-Fi network, you can then initiate training, like consequence management. So you can do it like behavior-based as well, which is a bit Big Brother, but... or send them Teams messages. You just joined you didn't use your VPN on this Wi-Fi network. You can do that. So, but I mean, it's like, we're not doing that because it is quite big. It's quite sort of
maybe
brother.
there you always have to, maybe like the GDPR is a little bit of a limitation as to what you can do like that.
Yeah, I suppose.
I noticed Ross was kind of saying we don't
do that. No, we don't.
But,
I know that products are like, I don't know if your company offer that as well. I know it's part of these phishing simulation companies. They do this kind of stuff as well. They have integration to your like EDR, and they can send you Teams messages saying, with training moments, consequence management, things like that. But that's the way it's going, you know. But you're right, GDPR is something.
Okay. I think you got a lot of new tips how to create the service.
Yeah, thank you so much.
So, yeah, somebody else? Are you still wondering? This is the chance now to ask what you have always wanted to know about cybersecurity and energy transition. There is another.
So, open source and malicious updates were mentioned. How do we know which ones are safe and which ones are not? I mean, open source is every day today. In your car, you can watch all the tens of open source libraries that are in the software running it, and probably in everything else we use, there's open source software, and there's been cases of malicious code being put into existing products.
Yeah.
So what can we do about
But that's what the SBOM is about. That's in the Cyber Resilience Act. So.
Yeah, but
It is a problem, yeah.
Yeah, it's real risk because no one, even from the software development side, no one reads the every code. They update 50 or 100 packages, and should they read every change there? No, no one does that. But basically, it starts already from the kind of, I would say, from the policy and process side. From my point of view, you should have, if you are developing software, you should have some way how to, some documented way how to manage the all third-party components and open source components. And probably good idea would be to use some software which actually shows what you are using, scans your repository, and then checks if you have some vulnerable version there in place, and somehow try to be on top what you have. It won't solve the issue that if some malicious update is pushed through to the specific component, but it will hopefully help. And one thing is also good to check that you are using components which are actually being updated, and you are not using something which has been updated 5 years ago, because those will become a bit risky at some point.
So it comes down to secure development life cycle, basically, following best practices.
Okay. I think we're kind of starting to look like we've given everything, all our answers, or am I reading the panelists and the audience wrong? Okay, bad joke again, sorry. But I think we're gonna, if there's not something in the streaming, Mansi, have you? There's nothing. Then I would like to thank you all very much, and a super big thank you to the panelists. You're gonna get your presents as well. And maybe if you want to give an applause to our fantastic And so, yeah, thank you very much for joining us, and see you again at maybe some point.
Thank you.
Thank you.
Thank you.
Thank you.